Hi, this is a help video for Rules of Exponents. Let's jump in. So this is 3.1 Rules of Exponents. Okay, put a box around that. You can use any kind of paper you want. You could even type them or something. I think it's hard to type all the math. Sometimes math is easier to write with on paper. Let's jump in first. What is multiplication? What is multiplication? Well, I'm sure you've been doing multiplication for many years in your life, but let's just go back and think about what it really means. What if we said 2 plus 2 plus 2 plus 2, right? We could say that. That's fine. And that's 2, 4, 6, 8. That's 8, right? But what we could do is say that this is 4 2s, right? There's 4 of them. So what we could say, or we could write this as 4 times 2, right? Because there's 4 of them. And that gives us the same answer. So this is our, how many, right? How many 2's did we add? We added 4 2's. So multiplication is repeated addition. That's what it means. Multiplying is adding. You're just adding a bunch of times over and over. So if that's true, we need something for repeated multiplication. What if we multiply a bunch of times? And that would be, let me get my camera a little better, that would be an exponent. So an exponent is repeated multiplication. There we go. Let's put a little cloud around that. Make it kind of pop a little bit. So let's give some examples. What if we did 2 times 2 times 2 times 2? Well, that's not 8. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Now, what's another way we can write this? Because this is, again, this is 4 2's, but now we're multiplying. So we can now say 2 to the 4th power, because this is our how many. How many 2's are you multiplying? And 2 to the 4th power is 16. Okay. So let's jump into the first rule of exponents. And this is what's called the product rule. Now, product means multiplication. So product means when you are multiplying exponents. All right, let me get my face out of the way here for a minute. Okay, product rule is when you're multiplying exponents. So let's give an example. What if you had, let's just take the general rule, x to the n times x to the m. All right, and we'll give some examples of this. But this is the general rule. So if you have a number to an exponent and you multiply it by the same number to a different exponent, what you get is x to the n plus m. Now, that's the rule. So let's highlight that, and then we'll give some examples so we can show what we're talking about. Okay, so that's the product rule. Let's take a variety of examples down here. Let's do, maybe let's go over here. So examples. Well, so let's do 3 to the 2 times 3 to the 4, right? So what does the rule tell us? It tells us we're going to add the exponents. But let's just slow down for a minute. What if we didn't know the rule? So 3 to the 2, what does 3 to the 2 mean? It means that there are, so that exponent tells you how many. So this says that there's 2 3s. So 3 times 3. And then this tells you that there's 4 3s. And that all of them are multiplied together. So you have 2 3s and you have 4 3s. That's those numbers right there. That's just telling you how many you have. So then you would have how many 3s? 1, 2, 3, 4, 5, 6. So you'd have 3 to the 6, right? Because that's the new how many. You now have 6. So if you notice that, that comes out to the same as 2 plus 4. So this is a nice way to say, yeah, you can write all this out, but you could just add the exponents. Let's do another example. What if you had x to the 7 times x to the 2? Right? Well, how many x's? 1, 2, 3, 4, 5, 6, 7 x's times 2 more x's. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 x's because these are all multiplied together. Right? They're all multiplied. So you have 9 x's. So you can just write that as x to the 9. So there we go. Cool. What if, just for fun, what if we had x to the 5 times y to the 2? Well, that's just going to be x to the 5, y to the 2, because this is, notice how the base, the x's are not the same. It needs to be the same letter. See, this is x and x, or 3 and 3. That number, that x number has to stay the same. Here we have different ones. So this one is like, this is like you can do it, but it's not the product rule because the bottom letter is different. So the base is not the same, right? So you can't do the thing that we were doing. Now, that's the product rule. Let's try another one, which is the power rule. So let's come down here to number 2, power rule. And the power rule is when you have an exponent of an exponent. So I'll show you what I mean by that. Let's slide the paper up. So what the rule is written this way, the shortcut rule for this, x to the something else. So this is some number to some power, and then the power of that. That's equal to the x to the n m. These are times now, right? X to the n times m. Now, let's kind of give some examples. Let's see how this works. So what if, move the camera a little bit, what if we have, well, I don't know, let's say 3 to the 2 to the 4th power. What does that mean? Well, leave out the outside for a minute. That means you have 2 3s multiplied together. So inside you have 3 times 3, right? And you still have the 4 out there. And then the 4 out there means 4 copies of this, right? So you've got 3 times 3, 3 times 3, 3 times 3. Oop, there we go. And I'm out of room. and 3 times 3. Kind of got a little crowded there. So I have 1, 2, 3, 4 copies of 3 times 3. Okay, well, how many 3s are there? 1, 2, 3, 4, 5, 6, 7, 8 3s. So this is not x. This is 3 to the 8th power because there's 1, 2, 3, 4, 5, 6, 7, 8 3s. Now, you might notice that 8 here, this 8, is the same as 4 times 2, right? And that's really what the rule is telling you. The rule is telling you that when you have an exponent on an exponent, you can just multiply the exponents. So yeah, you can write it all out. That's fine. There's nothing wrong with that. But you could just do 4 times 2 and get your 8. Let's do another example down here. What if we had x to the 3 to the, I don't know, 7th power? What would that be? That would be x to the 3 times 7. So that would be x to the 21. Okay? That's using our rule. The rule says if they're like this, you can multiply them. How about let's do a harder one? What if you had x to the 8 and then you did to the 1/2 power? Wait, what? Is that possible? Well, sure, it's possible. So what if you did to the 1/2 power? You would do x to the 8 times 1/2. And what is half of 8? Half of 8 is 4. So that's just a nice rule to say you can just multiply those. Okay, there's one more rule. So that's the power rule. Let's put some nice highlighting around that so we don't lose it. Okay. One more rule. The next rule is, this is called the zero exponent. Okay, zero exponent rule. The zero exponent rule is that any number to the 0 power is equal to 1 if, this is a big if, this is really important, if x is not 0. Okay, let me say that again. Any number to the 0 power is 1 so long as x is not 0. So let's grab a calculator here. Let's ask the calculator to give us some examples. So I'm going to pick a number. I'm going to pick 57. And I'm going to use this little up arrow right here. That's the up arrow. That gives me an exponent to the power of 0. What's it going to be? 1. Okay. What about 2.589? What about that crazy number to the power of 0? It's 1. It's 1. What about negative? That's some nasty number there to the power of 0. It's sorry. So this one is -1 because I left the negative. The negative goes as out there. Here, let me do that differently. If we did it like this, where it's in parentheses, that way the 0 power applies to the negative as well. Now it's 1. So when you look out here, what happened with this one is the negative was not affected by the 0 power because it was outside of the number. It was like in front of the number. Here, the 0 applies to the negative as well, and that gives us our 1. Now, what about the weird case? What if we did 0 to the power of 0? Well, the calculator says that's a problem. So we don't know what 0 to the power of 0 is. So if we do examples, let's do examples. Examples, we have, what about 3 to the 0 power is 1? How about x to the 0 power is 1, right? Okay, how about, and by the way, this is if x is not 0, right? How about 0 to the 0 power? Well, that is undefined, is how we say that, undefined, or you can say DNE for does not exist. That's another way to say it in math. So there's no answer to that. It's not a thing. 0 to the 0 power is not a thing. Now, I'm not going to get into today why the 0 power gives you a 1. I'll let you think about that. We will discuss this on a different day, why this is true. For today, let's just go for it. Just trust me that that's the case. So if you can always Google it, right? Why is the 0 exponent equal to 1? Google it. Find out for yourself. But we'll discuss it on another day. Cool. Hope that helped. Take a picture of your notes and send them in to me.